Hello, this video goes over the enol-aldol reactions. Aldol reactions are when an enol or an enolate add directly onto another carbonyl species. In enol conditions, so when we have an enol adding, we need to prepare our carbonyl so that it's a good electrophile. We do that by protonating it. And so now this protonated ketone, for example, is a good electrophile. On the enol itself, the lone pairs come down to form a pi bond between the carbonyl carbon and the oxygen. And the pi bond between the carbonyl carbon and the alpha carbon attacks the protonated ketone, just like that, so that we form this intermediate. Just like so. We deprotonate. And we find ourselves with the alpha beta hydroxyketone adduct. So this is the addition product that, if the reaction specifically states that it's low temp, we are able to stop here and say we can form only the alpha beta hydroxyketone adduct. However, normal aldol reactions without any specific mention of temperature, or if it says high temperature, they go to the condensation product. To go to the condensation product, what we first have to do is protonate this ketone to reform our enol. So, a hydronium ion can protonate the oxygen on this ketone so that we form this intermediate. Then water will deprotonate it, the alpha carbon, just like so. The negative charge forms a pi bond. This pi bond breaks. And we have reformed our enol. Now what the enol does is that it brings its lone pairs down, and this pi bond shifts, or before that we protonate our alcohol group here. We need to make this a good leaving group, because this is going to leave so we can then condense. Right, now the lone pairs come down and the pi bond shifts so that we can kick out water. We have this intermediate which is deprotonated, so we can form our final and condensed product, which is the alpha beta unsaturated ketone, which is the final product of an aldol condensation in normal conditions.